In this video, what I'd like to do is introduce welded connections for steel design and construction. Honestly, the best way that you can learn about this is not from this video. I'm going to cover some of the basics here and some of the things that I would like to emphasize and point out. But your best source of information for this particular section of the course is to actually read on pages 519 through 525 in the textbook. The textbook is pretty informative with regard to welds, far more than I can be standing here and trying to dictate what welds do and how they behave. And there's lots of figures in there that I would just have a hard time drawing here as well. And it doesn't do me any good to just recreate everything that's in the textbook either. So, in short, I'm going to refer you to the textbook, page 519 through 525. You should spend some time with this with regard to your concept worksheet anyway. By definition, a welded connection is the process of joining metals by fusion without any pressure. And in general, what happens is we transmit an electrical energy source down through a wire, and we create an arc. And that electrical arc then generates heat. And the heat melts both the welding rod and the, if we're talking about arc welding that is, melts both the welding rod and a little bit of the metal that we're trying to fuse together. And this happens at a very high temperature, and as that molten metal cools, it solidifies. It creates this homogeneous conglomeration of the metal that was melted together. The primary reason that we want to do this is to be able to transfer moments through our steel connections, and it's probably the best and most common way to create a truly fixed connection that has the ability to transfer bending moments from a beam into a column or across other sorts of members. In general, it's a pretty common way simply to connect structural steel together. So what I'd like to do now that we've kind of talked about this, you can read more about that in the textbook, a little more detail with that, but wanted you to be quickly aware of the definition and how it takes place. But really what I want you to be able to do after watching this video is be able to identify different types of welds and identify those that are most common. You're going to see a lot of welding symbols in the plans and perhaps the specifications as you're going through construction documents, and you should be familiar with what those are. And so there's three basic types of welds that we encounter. We have fillet welds, plug or slot welds, and groove, or sometimes called butt welds. And the standard symbol for a fillet weld is a triangle, a right triangle in fact. The reason being, if I was to draw two pieces of structural steel here and we wanted to connect those together, I'll draw the weld with red. We would actually, this is a cross-section view, we'd actually fill in between those two elements there, and the symbol might look something like this, where we see the triangle for the fillet weld, and it might even notate the size, a 1/4 inch fillet weld connecting those two materials together. It's one of the most common types of welds. Groove weld is the other most common type of weld that you will see. But the major difference is fillet welds are designed to carry shear as well as tension and compression loads, whereas groove welds are typically used for just direct tension or compression. So anytime you need to make sure and transfer shear across a connection, a fillet weld would be the one that we would want to use. All right, a plug weld. It's a slightly better diagram in the textbook, but I'll try to replicate it really quickly here. If I have a piece of steel plate and I need to connect that to another piece of steel plate, oops, I almost got that there. All right, so you get the idea here. We've got these two steel plates that we'd want to connect. Technically this line, whoops, let's erase that line right there and extend that out just so it looks like we're extending these plates a little further than what I'm showing there. What we often will do is have a hole in one plate or maybe a slot in one plate, and then what we'll do is we'll go ahead and weld through that hole. That's noted as a plug, or we would completely fill in this slot with a weld, and that would be known as a slot weld. And oftentimes the symbol for that, you'll see a circle, sometimes you'll see a rectangle, and those are common ways to notate that. Groove welds actually come in multiple, let me actually move this over to this other side. Groove welds come in multiple types of configurations. Your textbook has a number of those, but the idea here is if we're butting up two pieces together, let's say these are square pieces right here, you might see a weld then that goes ahead and fills in the gap between those two pieces of metal right there, and we would notate that with a symbol that notates the orientation of the two pieces of metal, and this one gets called a square groove. The cool thing about these is you can actually see the shape or the configuration of the weld in the actual diagram symbol that is used. The next one that I like to quickly notate is occasionally we will have a piece that we will taper down like this, and we call this one a single V groove. V for the shape, although they do spell it this way right here, VEE. And it's notated by, again, filling in their symbol. Looks like a V. In this case, it's upside down from the way it's oriented. Those should be straight lines. And looks something like that. Also common to have a double V, so rather than the weld only being on one side of the materials, we actually weld both sides. It's like putting 2 points together. Symbol for this one ends up looking more like an X, but you can see that double V shape in there. Those three right there have to do with kind of butting up two pieces parallel to each other. The next three have to do with more of a perpendicular configuration. And so if we had a plate down here and wanted to do one perpendicular there, this one would be a single bevel T. Again, T makes the shape, meaning perpendicular, but they do spell it T-E-E. And symbol looks like that. We could also do a double bevel T. So here's our plate. Material comes down, forms a point. double bevel T. Raise the screen up just a little bit. And we're again filling in the welds on both sides. See a symbol that's called out like this. Looks kind of like a K on there. And occasionally what we'll do is we'll see looks a lot like a single bevel T, but rather than a straight section, I'll exaggerate it here, it's curved. I'll make it a little bigger so we can exaggerate that. Go ahead and weld that in there, and this one ends up looking kind of like an H on there. And this one again was called I didn't say what it's called. This one's called a single JT. Not sure why they simply refer to that as a J without spelling it out like they do the other ones. But there you go. Some common types of groove or butt welds. One other thing I'd like you to do, since I've hand drawn these here, is there's a lot of welding charts that exist on how to recognize what these are. In your textbook, if you go to table 10.4, you would see an example of one of these. And note the symbols. There's actually a couple more in there. There's a U that I didn't show. Talks about whether it's flush or convex. It doesn't have concave on there, but that's another one that exists. This diagram here is from the Steel Construction Manual, and it goes through in a little more detail the standard symbols that are used for welds. In general, I want you to be able to identify these ones that I've gone through here, both by symbol, and then be able to generally describe what they're used for and how to connect the materials together. If you can get through that, then you've accomplished my intention for the types of welds and the symbols that are notated there.